Hello class, I'm going to show you how to make a graph, starting with the data and then finally plotting the data. So the first thing we want to do is look at the data. So we have here a data table, and there's going to be some information to give me some meaning for this data. So the effect of temperature on the action of pepsin, a protein digestion enzyme present in stomach fluid, was tested. All right. And you can skim that if you want, but basically, I know that temperature is the independent variable, and amount of protein digested is the dependent variable, because temperature affected the amount of protein digested. So I know that temperature is going to be in the x-axis here. And in fact, that's what I already have. On the x-axis, I have temperature, and on the y-axis, I have amount of protein digested. And we're already given at the top a title as well. Now the very first thing I want to do is first figure out what kind of graph am I making. Now I'm looking at the data and I see both my independent variable and my dependent variable are numerical. They're numbers like 5, 10, 0.5, 1.0, etc. On the living environment regions, sometimes it will have you make this into a line graph, right? They give you a little example of dots connected in the lines, and that's what they want you to make, is a line graph. Personally, I disagree with that. I think line graphs should only be used for time, but if you happen to take the regions and it tells you to make a line graph, just make a line graph. All right, but because this is numerical data, I'm going to make a scatter plot. I'm making a scatter plot. Now that I've identified what type of graph I'm going to make, now I want to scale my axes. So temperature on the x-axis goes up to the number 85. So I need to capture the number 85. So I'm going to go and count how many boxes I have to jump from. I've got 2, 4, 6, 8, 10, 12, 14, 16, 18. Looks like I have 18 boxes. I'm just going to do some simple math here. So I need to get to 85, and I'm dividing that by 16. So 85 divided by 16 is 5.3. That's a really ugly number. I'm not going to do that. I'm going to keep it simple. I'm going to go round that up a little bit, and I'm going to go by 6. I'm going to round up only. So that means whenever I hop, I'm going by 6. So 6, 12, 18, 24, etc. That's going to be a lot to write out. So what I'm going to do is actually only mark every 2 boxes. You notice how that line is a little bit thicker, which is probably what the designers of this graph wanted you to do. So if every single box is 6, then every 2 boxes is 12. So that's what I'm going to do. I'm going to make first a scale for my graph. So I'm going to start at 0, of course. And since I'm starting at 0, now I go to 12, 24, 36, 48, 60, 72, 84, 96, and this would be 108, I believe, if my math is correct. And so what's great about this x-axis is I'm going beyond the data. The data only goes up to 85. So all of my data will fit into the graph. I should not be like adding extra lines over here or something. All the data is going to fit. So I'm going to repeat that for the y-axis. So the y-axis goes up to 9.5, and that's just about 10. I'm going to round that up, make it simple for myself. Be 10. And again, I'm going to count how many boxes I have. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So 10 divided by 20. 10 was the data I'm trying to capture, and 20 was the number of boxes. Gives me 0.5, which means every 2 boxes is going to be 1. 0.5, 1. So I'm just going to jump every 2 so that I don't have to make a little number for every single one. Save myself some time. All right. And so this first one will be 1. To move that a bit. To copy and paste this. You've got 2. Obviously, if you are drawing, it's going to be a little bit easier. But for the purpose of what I have right now, I'm just doing it this way. I also like doing it this way because I have very bad handwriting. Very, very bad. So by typing it out, it looks much nicer. Now, in the real world, scientists very rarely would draw a graph by hand. However, the skill is still very important because it allows you to understand how graphs work. If you can't make a graph, then there's a good chance you don't know how graphs work, especially scaling. That's probably the most common error that students have, is they scale incorrectly. So for example, notice how I started at 0 and jumped up to 1. A lot of students would just start at 1 and forget that the 0 is supposed to be there. It's a very common mistake. So you want to make sure that you're starting at 0. If I wanted, I really could have put like a 0 here as well on the y-axis, but I already wrote it on the x-axis, so I didn't bother. And starting at 0, for the purpose of this class, you're always going to start at 0, but in the real world, there are many graphs that do not start with 0. But for our purposes, start at 0. Okay, so now that I have both my axes set up, I can start to plot my data. So let me look for my first data point. Tube 1, a temperature of 5, and amount of protein digested 0.5. Notice, by the way, that the unit of measurement was given. I know it's Celsius, not Fahrenheit. I know this is in grams, not ounces. So 5, 0.5. So temperature of 5 would be around here, and 0.5 is around here on the y-axis. It's going to insert, I'll just make a little circle. I think that'll be easiest. And I'm going to make it my favorite color, which is orange, just because I can. So that's right about around here. Next one is 10 and 1. So 10 is around here, and then 1 is up here. So I'm just going to copy paste that. Boom, 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 like that. Next is 20 and 4. Paste. 20 and 4. Around-ish here. And notice this is going, the data plot is going pretty quick because I already have my scale set up well. 37 at 9.5. 37 is just past here, and then it's at 9.5. Around here. And then 85, 0. 85, whoop. 85 is around here, and then 0 on the y-axis would be right on the line. Remember that line means 0. Okay, so these are my data. So just to review, first started with the data and asked myself, what kind of graph am I making? For this example, I'm making a scatter plot because I have two numerical data sets, on the x-axis and the y-axis, the independent variable, the dependent variable. I scaled both axes by looking at the biggest number, here 85, and scaling evenly so that I could reach 85. And the other one I needed to get to 10 about, so I scaled up to 10. and then I went back to the data and plotted. All right, that is how you make a graph.